In this lesson, we'll apply some loading to our model. All right, so we're ready to apply some loads to this model that we've created and basically synced up to. So it's very important that when you try to run your analysis that you apply your loads first. So I'll show you what will happen if you don't apply your loads and some of the messages that we'll actually get. So if you wanted to run an analysis, we'll go to Analysis. Let's assume that we're ready to run it. We'll go to the Structure tab. Right under here, I'm going to Analyze in Cloud, and once I click that, I'm going to let Revit do its thing. So what it does here, it basically analyzes, does like a little pre-check before it sends it to the cloud to be analyzed. And as I suspected, I get a couple of error messages. Now, if you're new to running these analyses, you might get this, but don't be freaked out. I'm going to show you how to deal with this. So this is telling me that the analysis cannot be performed for this model. Errors have been detected. So I'm going to say, OK, and I'm going to read these error messages. So it says, the material assigned to the element does not have physical assets. So I can tell that these two walls that are highlighted in dashed red are the ones that we're talking about. So I'm going to have to go back and look at that, but I see I have a second message. And it's telling me my loads are not defined. So whenever you're running your analysis, make sure you know your loads are in place, but two, make sure everything has material with physical properties. Now I think we applied material with the physical properties to our floor, or both of our floors, but we didn't do it to our wall because we assumed it already had it because it was a structural wall. Well, now this is a really good exercise on how we can get this accomplished. So I'm just going to select both my walls. I'm going to edit that type, and I'm going to come into the structure, and we're going to do what we did in the earlier lessons, and we're going to come here, apply material to it with physical properties. Now this is just a real simple concrete wall, but it does have physical properties, and I know so when I click this, I can see this very important information. So I'm going to say OK here, and it's applied there. So we'll say OK, apply, and OK. So that should take care of that for us. But now we need to apply some forces to this model. So I'm going to adjust my view here just a little bit. And let's see if maybe we can run this in the analytical model. That might actually work for us. No, we'll go back to this regular model. And we'll start applying some loads to this guy. So first one I'm going to do is maybe I want to apply a wind load to the side of my building because I want to see how this building will react and deform with a certain kind of a load applied to it. And I wanted to specify the direction and also magnitude of that load. So up here in the upper left, we've got loads. I'm going to click on loads. And here you'll notice we have 6 different kinds, but essentially there are 3. Point loads, line loads, and area loads. But we have regular ones that you just place, but we also have hosted. So hosted is you could basically place a load on a selected endpoint of a beam. And let's see, the main difference between this one is it just places a load on a sketched point. So that's the main difference. You're placing it on an element and you're placing it on a sketched point. So what we're going to do is we're going to apply our area load. So I'll say area load here, and I'm going to pick a plane, pick the face of that wall, and I'm just going to draw in the shape of this force. So I'm going to say I want it to hit, all along this wall here. So from there, before I hit my green check mark, I can come to my properties and I can now start specifying some things. So for this one, it's going to be a wind load, so I'm going to select wind load. But I also want to mess with the direction as well as the magnitude. So I wanted to specify what direction, X, Y, and Z, and also how many kips per square feet does this particular load have. So how I remember this is f of x, or basically the forces moving for f of x here are going to be moving in the east and west direction. Now either negative or positive for left or right. And then f of y is going to be moving in the north and south direction. Positive and minus depending on what direction you want to go. F and Z, up and down, positive and negative for which direction. Negative is down, positive is up. So in our case, I can tell by my view cube, I want that wind to go this way, which is going in this east and west direction according to my view cube. So I'm going to come here and I'm going to plug in some crazy large number here so we can see the effect of that deformation. And I'm going to turn that off and I'm going to say apply. Green check mark it, and boom. Now, had we not made that adjustment here, that force would have automatically, by default, come in as a dead load in the negative direction like we saw earlier, and it would have been coming down. So it's going to be important that you pay attention to your direction and also your magnitude of your forces. But we can also apply different types of loads. Let's say I wanted to apply another load somewhere onto this model. We can do so. We can come and go back to loads again. And let's say we want to do another area load, and maybe we could place something here on this balcony. And you can see it's placing it as if we're placing it on this plane. So we need to go ahead and set a new plane. So I'm going to pick plane. Actually, we might just be able to pick level 2. I'll say OK. And I should be able to now sketch this onto that surface. And I can. Just like so. And I might not want this to be so far out. Maybe I want this to be a little bit more concentrated. I can adjust that. I can come back here. I know that this is going to be maybe a dead load. And I can specify how I want this to work. So this dead load is going to be moving in the down direction. So we're going to have to make an adjustment here. So we'll say 0 there, and it probably won't let me do it, but there we go. Awesome. So we'll go in the Z direction. We'll say negative 15 kips per square feet. And we can apply, green check mark, and there we go. Now, depending on how large your force is, that's going to determine how long this is. So because we have 25 kips going in there, this is so long here. The same thing with this one. This one's pretty large, so you're going to see it. So smaller forces means smaller arrows. So that's why this looks large, so don't be alarmed if you see that. So at this point, we've got our loading set up, and we also took care of the other warning we had with our materials. So what I'm going to do now at this point is I'm going to save it. So we can say save our project. And now I can come here to my structural analysis area, and I can analyze in cloud, and we can give it another shot. And we'll see what kind of message we get. We followed and corrected all our error message, so we should be able to do a quick analysis. And it looks like things are going good. I usually know when something bad has happened because I won't be able to get past this verify the model point. So things are awesome. So we'll get this message here. We're going to make sure we have add existing load case. We're not going to have ignore here, but this gives us some opportunity to kind of place some information in our model. So let's say this analysis here. We'll call it analysis 1, but we can also type in a name if we wanted to. Report name, we can say small building report if we want to, whatever you want to put in there. But now I'm just going to go start analysis, and it's going to take just a little bit of time. But when you're doing this, don't be alarmed if you don't see anything for a while. It's just your information is being uploaded to the cloud, being computed, because you got to remember, you're doing some pretty complex calculations here. Engineering and load calculations and analysis isn't that easy, so it's all happening in the cloud for us. But at the bottom right of your computer, you'll notice in the area where your time and your date are, if you expand that little area, you'll notice a little rainbow colored box that actually looks like it's glowing a little bit. If you hover over that icon, you'll notice it'll say structural analysis for Revit, and you'll have a pending analyses as well as messages. So you should see 1 for pending analyses if you wanted to make sure your analysis is running, because we have 1 going. That's the one that's going, so we're in good shape. But once it's ready, in that same bottom right corner of your screen, you'll actually get the yellow box, and it'll say, hey, your structural analysis is ready. You can click on that, and it'll open up the PDF for us. So what I'm going to do is I'm going to pause here and wait for my results, because it may take just a little bit. And when I come back, we'll take a look at those results really quick. Awesome. My results are now ready. And what I did was I clicked on that little yellow box that appeared and let me know that my results are ready on the bottom right-hand side of my screen. So I can now take a look at this. So we got small building report, the name, and we can take a look at what we have going on. So we have a number of things going on in this report. So we have our structural view, which is just a general view of the structure. We also have a model of the structure continuing through. We also have our loads, so we know what kind of loads we're dealing with. We have the load combination, the one we actually specified as well as the formula. You remember that in our previous lessons. We have our reactions. This shows the reactions in the coordinate system. It's the sum of all of our reactions as well. Pretty interesting stuff. We've got some more graphics here showing the number of nodes for the extreme reactions. We have all the forces in each member. Pretty interesting stuff, huh? So this is really cool. So the more complex your model, the more complex this report will actually be. And we can get to the point where we can actually save this if we wanted to. I can either save this page or I can save this as a PDF by clicking on this little PDF, and I can save the file wherever I want to. So this will come in handy if you need to share this with other team members or you're sharing with a professor if you're a student. So this is the way you can actually get that done and just save that wherever you want to. So that's how you actually run the analysis, prepare for the analysis, and take a look at the results and also save the results. So in the next lesson, we're going to take a look at how we can explore those results, and we're going to take a look at how a Revit figures out how our building will deform and perform underneath the loading scenarios that we put in place. So I'll meet you in the next lesson. I'll close out of here, and we'll go ahead and start exploring this, the results here by clicking under this and going to our Results Explorer. So I'll see you in a bit.